Hey everybody, this is lesson 3 in unit 4 where we're talking about triangle congruence. In this lesson, what we're going to be focusing on is proving triangles are congruent using these theorems that we're going to talk about pretty much the remainder of the unit, side, 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 or SSS and SAS. So in this lesson, we're going to be using side, 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 and the side angle side to determine if triangles are congruent. That's the first video. And then the second video, we're going to start working through proofs. Some of you may have heard of proofs before. We're going to make it pretty uncomplicated here if you just watch that second video. So let's see here. There will be a reference sheet as well as some guided notes that should be provided and passed out to you before you start this. So just make sure you fill those out as you watch this video. All right, so in the last lesson, we basically talked about how do we know when triangles are congruent. So we did say that triangles are congruent when all of the angles and all of the sides have like a matching corresponding angle and side. So in this case, if we're looking at these two triangles and we happen to know that those two angles were congruent, or those angles and those angles, and then also these sides are all congruent, we would say that because each side has a corresponding congruent side in the other triangle, and each angle that has a corresponding congruent angle in the other triangle, because all of those match up, all 6 here, it means that the triangles are congruent. Now, what we're going to look at today is basically how do we know if triangles are congruent if we have limited information. So maybe we don't know all of those 6 pairs of things are all congruent. So that's where these theorems come in. Now, if you had the reference sheet available, you should be able to see all of these kind of listed: SSS, SAS, ASA, AAS, and then HL. Today, what we're going to do is focus on these first 2 here. And again, make sure you're following along on the reference sheet, marking these things as you're watching this PowerPoint, as well as when we get to the examples, filling those out while you watch this PowerPoint as well. All right, so side, 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 this is just a theorem that is a way to prove that triangles are congruent. It basically says that when you have 2 triangles, see here, if you have 2 triangles and they have 3 pairs of congruent sides, that'd be like these are congruent, these 2 sides are congruent, and these 2 sides are congruent. So we have 1, 2, 3 pairs of congruent sides. That is enough to say that the triangles are exactly the same. So again, we're kind of skipping over this idea that you need all of that information, like all of the angles to be congruent. As long as you know that all 3 pairs have, like, all 3 sides have a matching corresponding side in the other triangle, then they're congruent. So again, if all 3 sides of a triangle have a corresponding congruent side in another triangle, meaning that in this triangle, this side would be corresponding to this side, this bottom side would be corresponding to this bottom side, and this side would be corresponding to that side. Since all 3 sides are congruent, then the triangles are congruent. All right, now we'll look at SAS. SAS is side angle side. So this is true when you have 2 sides that are congruent, meaning that you have 2 pairs of congruent sides, and then an included angle. So included angle really means that they're talking about, it has to be the angle that's between your 2 pairs of congruent sides. So in this diagram here, if we wanted these triangles to be congruent by the side angle side, we need it to be these 2 angles to be congruent right here. Because then it would be side angle side, side angle side. Hopefully that makes sense. So if you have this side angle side congruence going on, it is also enough to say that these triangles are in fact congruent. Okay? Now, these reasonings here are something that we're going to be using more specifically in proofs, but this is also on your reference sheet. Reasons why sides can be congruent is it's given. So if they like actually deliberately tell you, or those congruency marks on there, that means that the sides are congruent. Another way that you know sides are congruent is if they tell you some like point is a midpoint. that means that that point is right in the middle of two other points. So it creates two sides on either side of the midpoint that are congruent. And we'll look at examples of these too. Reflexive property is a really important one. This is basically saying that the side is the exact same, is congruent to itself. And we'll look at the reflexive property here shortly as well. And then the reasons why angles can be congruent is it's given. So if it's marked congruent, like on the diagram, they mark it with a little arc mark, or they deliberately tell you that angle whatever is congruent to angle whatever. So that's how you know those angles are congruent. You can also have congruent angles with all of these angle pairs that we've talked about in the past. So vertical angles, alternate interior, alternate exterior corresponding. And these ones, you must have parallel lines to do that. And then we will look at a problem later on too that deals with the definition of an angle bisector. So if they say that some line bisects an angle, that it's going to basically, if you take a line and it bisects an angle here, what you're doing is you're creating two angles on either side that are exactly the same. They're congruent angles there. We'll look at these in depth here on the next slides for examples here. All right, so this is where you can start filling in your guided notes here. Example 1. So these problems are going to be very similar to what you're going to have to do on the test over kind of these SSS, SAS, and whatnot. So it says determine if the triangles are congruent by SSS, SAS, or if there's not enough information. If they are congruent, write a congruency statement. So a congruency statement is just basically the correspondence, writing the letter of the order, or order of the letters in the correct order. All right, so when we take a look at this diagram here, you should notice that these marks mean that these sides are congruent. So, and then we also have that these marks, the two tick marks here, tell you that those two sides are congruent. So right away, just looking at this diagram, you should be able to say that QY, so this side, is congruent to CK. And then we could also say that TY is congruent to PK. And again, the order of the letters does matter. Notice how TY is the two marked side. It goes from T to Y, which has the one arc mark. So it has to a PK in the other triangle. Now, that's given information. So that's why we know that those sides are congruent. And then we also know that this angle right here is congruent. So we could say that angle K is congruent to angle Y. This should be a Y. I'm going to fix that real quick. And then you should notice that as you kind of write out, like in the specific order, like here we have a congruent side, congruent angle, congruent side. So it is side, angle, side, congruence. So we know that these triangles are congruent because it meets that criteria for side, angle, side, side, angle, side, congruence. So because they're congruent, we can then write this congruency statement that says QYT. So if I did QYT, it needs to be CKP. So we would say those triangles are congruent by SAS congruence. Okay, example 2. Example 2, determine, we're doing the exact same thing. So if we look at these two triangles here, notice how these two sides are marked congruent. So we know that AD, so we know that AD is congruent to BC, or CB, excuse me. We know that DC is congruent to BA, because those are all marked congruent. Now, what you should also notice is that in these two triangles here, they actually share this side AC, right? So because they share a side, it means that this side is going to be the exact same length in both triangles because it's the same side. So this is where that reflexive property comes in, where you're saying that this side AC in this triangle, the bottom left triangle, AC, should be congruent to the side CA in the upper triangle. That's what the reflexive property is when you're saying a side is congruent to itself, because this should be the same length in both triangles because it is a shared side. It's right where they meet. So here what we have is a pair of sides, another pair of sides, and then a third pair of sides that are congruent. So these triangles would be congruent through side, side, side congruence here. So we would say triangle ADC, ADC would be congruent to triangle CBA. by side-side-side congruence. If these are troubling at all, just rewatch these videos until you fully understand exactly kind of what's being said here. All right, example 3. Here what we have is another pair of sides. SU and TU are congruent, and then also TW and SV are congruent. And then they also tell you that this angle here, these two angles are congruent by these arc marks, right? Oops. So these angles SUV, so SUV and TUW, they arc mark congruent. But if you notice how like I have the order here, it's SSA congruence. That's because this angle is not in between the two pairs of congruent sides. So if we wanted to use SAS congruence here, it needs to be this angle right here. It has to be congruent to this angle T right here. So in this case, because the angle that is congruent is not in between, or is not the included angle with these two sides, then this is not enough information here. There's not enough information because it's not SAS, because this angle should be in between those two sides. Right? Next up, this one should look fairly familiar to one of the problems that we did in the triangle scavenger hunt, where you have these parallel lines here. That's what these little arrows mean here. So first off, they tell you that JD is congruent to EM, or ME, excuse me, and then also DA would be congruent to EA, because those two sides are marked congruent with those marks there. So we know that those two pairs of sides are congruent. The parallel lines here basically tell you that you're going to have these. So, well, first of all, you should be able to recognize that we have vertical angles here. But again, with these vertical angles, these angles are not in between, or not the included angle here. So these vertical angles aren't really going to help us out in this problem yet. But because these lines are parallel here, it means that these angles that are on alternate sides of this transversal, alternate interior angles, will be congruent. So that does mean that angle JDA is going to be congruent to angle MEA. And then because that angle is in between those congruent sides, that's the included angle, that would be SAS congruence. So we would be able to say that triangle JDA is congruent to triangle MEA by SAS congruence. Last example here. Again, if you need to rewatch these as many times, do that as many times as it takes to get this. We're taking our time with it. We'll work through it over the next course of the couple days, but you should be able to grasp this stuff just by rewatching the videos. All right, the last one here. This is actually a good problem because it leads into being able to do proofs, which is what the next video is about. So here, the given information here says that JM is congruent to NM. So anytime, this is how proofs are kind of written. They give you some information. They tell you what they want you to prove. In this case, they want you to prove that the triangles are congruent. They tell you that JM is congruent to NM because it's given. These are our reasonings here. We also know that JL is congruent to NL because they say that L is the midpoint. So L is the midpoint of JN. So if L is the midpoint here, that means the distance from J to L is the same as the distance from N to L. So that means that those sides are congruent. Okay, and then you should also be able to recognize, because these two triangles share this side, LM, that we can actually say that that side is congruent to itself in both triangles. And again, that is the reflexive property. Anytime that you're saying a side is congruent to itself, it is the reflexive property. So you should be able to notice here that we have side, side, and then side congruence. All three pairs of congruent sides are congruent in the triangle, so triangle JLM is congruent to triangle NLM. Side, side, side congruence. All right, that's it for the examples. You should be able to complete problems 1 through 8 on the assignment. After you complete 1 through 8, come back and watch the second video about proofs. That one should be hopefully a little bit shorter here, but you should be able to get the gist. All right, thank you.